Hello and welcome to this video on multiplying and dividing fractions. If you're here, this video assumes that you have some background in this. It's meant to be a refresher, so it takes a little liberty with the speed at which it proceeds. So just hold on to your socks and let's get going here. Pretty much the basics that you recall from the rules for multiplying and dividing fractions are as follows. In multiplying, you try to simplify using GCF. GCF is greatest common factor. And you multiply straight across numerator with numerator, denominator with denominator. We'll show that in some examples, obviously. Division, when we divide, it's a little different. There's no such thing as division by fractions per se. You change divide in the multiply by the reciprocal. Okay? So reciprocal, real basically, if you have 2/3, its reciprocal is 3/2. It basically means to just invert the fraction or flip it over. And then you'll multiply straight across. So again, it's the idea that divide becomes multiply after you use the reciprocal. Okay? Just real basically, we're going to look at simplifying these fractions on their own before we move forward in the multiplication and division. The question we ask, if you're being asked to simplify 5/15, is not, does 5 go into 15? That's something that people fall for all the time. I think it builds a very bad habit. You don't want to ask yourself, does 5 go into 15? Even though it does. Because here, if you ask yourself, does 24 go into 36? Or vice versa, you'd get an answer in no, and you think, oh, I can't simplify it. That's not the actual question you're supposed to be asking. It's what is the GCF of the numerator and denominator? And in layman's terms, it's just what's the biggest number that goes into both. So what's the biggest number that goes into 5 and 15? It's 5. So you divide 5 by 5 and get 1, and 15 by 5 and get 3. So your answer here is 1/3. Similarly, I asked what is the largest number that goes into 24 and 36. Again, that's just layman's terms for the GCF. And I should note that it's 12. Okay, so I divide the numerator by 12 and get 2, and the denominator by 12 and get 3 for an answer of 2/3. Okay, so again, you want to pick the largest number you could simplify by. It prevents you needing to do multiple steps. Okay, so let's move on. So multiplying fractions. Okay, I have 3 examples here. They're all trying to highlight something a little bit different. In the first one, it says -10/7 times 14/15. Well, one of the things that people tend to say is, well, is the 10 negative or the 7 negative, or are they both negative? Well, they can't both be negative because a negative over negative would be a positive, and it says -10/7. So one thing you want to do is you want to have a sense of just associating the negative with the top or the bottom, numerator or denominator. Okay, so from there you can proceed and say, let's simplify using GCF on this bow tie type of shape. Okay, and you can sit there and say, does anything go into -10 and 7? No. 7 and 14, though? Yes. 7 goes into both, so I'll divide both by 7. Get 1 here and 2 here. Then continuing to look, is there a GCF of interest other than 1 for 2 and 15? No. But what about -10 and 15? There is. Again, I don't ask, does 10 go into 15? Because my answer would be no. I ask what goes into 10 and 15, remembering that the 10 is negative, and that answer is 5. So here I would get, dividing by 5, I would get -2, and dividing by 5 here, I would get 3. Now you're going to multiply straight across. -2 times 2 is going to give you -4. And then we have that 1 times 3 is going to give you 3 for an answer of -4/3. Okay, on to problem 2. Similar process here. I notice I have a negative, so I'll tend to associate that negative with the numerator and call it -12/5. It's still a negative number. And then I'll look vertically and diagonally for GCFs. The one thing you need to realize is you can, because of the commutative property, you can skip over terms. You can look for a GCF kind of skipping over a fraction because the order doesn't matter. Notice the different symbols here for times. You need to be fluent in those. You should be by the time you look at this video, though. Okay, so there's no GCF for negative 12 and 5, or 5 and 14. 14 and 30 there is, though, so I'll simplify there and say, what's the biggest number that goes into 14 and 30? In this case, it's just going to be 2. So this turns into 7 when I divide by 2, and this turns into 15. You could do this a lot of different ways in different orders. Here I notice does the GCF apply for negative 12 and 15, and then it does, and that number would be 3, so I'll divide this by 3 and get negative 4, divide this by 3 and get 5. Continuing to look on the GCF plan here, I do have a GCF of 2 and 4, and that is going to give me a GCF of 2, so dividing both by 2, I'm going to get 1 there, and negative 2 here. Okay? I don't seem to have any more GCF, so I'll go straight across for negative 2 times 7 is 49 times negative 2 is negative 98. And across all the remaining denominators, 5 times 5 times 1 is 25. Okay, so that answer is negative 98/25. Okay, on to number 3. Just to kind of highlight this example here, you really can't do this GCF examination in this problem just yet because you have 4 and a fifth. You need to write that as an improper fraction, so I'll do 4 times 5 plus 1 is 21, and keep my fifths, so I get 21 fifths times negative 20 over 7. If you notice, I associated the negative sign with the numerator here. Okay, so now I look for a GCF, again in that bow tie shape, butterfly shape. This is not cross-multiply, by the way. Although you're multiplying and there's this cross sense of it, cross-multiply is a whole other thing. Okay, so what is the GCF of 21 and 7? It's going to be 7, so I'll divide both by 7. Get 3 here and 1 here. What's the GCF of 5 and negative 20? That's going to be 5, so I'll divide by 5 here and 5 here. I just get 3 times negative 4 is negative 12 over 1 on bottom. I'll illustrate this with a magic pen. Once you realize it's going to be 1, you don't have to write it. In fact, you shouldn't. And if you do, you better go one more step and take it out, or rewrite it just as negative 12. Okay? Writing negative 12 over 1 is not simplified. Let's move on to division. Okay? Again, we are going to multiply by the reciprocal instead of divide, as it's indicated in the problem. Some people call this the keep, change, flip method, where if you see we have 1/7 divided by 1/7, I will keep the 1/7, change the divide to multiply, and flip the divisor to get 7 over 1. Now intuitively, anything divided by itself should be 1, and now you see when I set the problem up this way, it's going to make sense because I'll be able to look for a GCF for 7 and 7. In fact, it's going to be 1. Multiplying straight across, you just get 1. So in number 2, where we have 6 and 2/5 divided by 4/3 squared, just a little bit of a curveball here, trying to incorporate the idea of order of operations. You do have an exponent here that needs to happen first. Okay, I can convert this to an improper fraction and go 5 times 6 plus 2 is 32, excuse me, wrong pen, 32 over 5, right? I'm still going to write divide because I'm not changing this yet, but I'm going to square the 4 and square the 3 and get 16 over 9. And then to do keep, change, flip, I keep the first fraction, change, divide the multiply, and then flip the second fraction to use the reciprocal so that it's 9/16. And then I'm asking myself, does 32 and 5 have a GCF? 5 and 9, the answer is no to both. 9 and 16, also no. So we notice 16 and 32 does, though, and it's 16 that goes into both. So now I'll multiply straight across. 2 times 9 is 18. 5 times 1 is 5 for an answer of 18/5. Okay, a little more work down here. Again, some PEMDAS in number 3 where the order matters because of the parentheses. We're going to do some rewriting here. I'm associating the negative with the numerator. I'm writing -6/5. Excuse me, I'll try and write a little neater. I'm using a slate, so it's a little difficult. So times 14/30 divided by 21/2. Okay, I'm just going to be patient with my writing here. I'm going to write that again as -6/5 times 14/30 times the reciprocal of 21/2, which is 2/21. Okay, now that it's all multiplied, I can kind of go out of order here. Okay, so you realize the parentheses in the beginning need to be addressed, but as it becomes all multiply in the end, it's really not going to matter. Okay, so now I'm just looking for GCFs. I notice that -6 and 30 have one of 3. So I get -2 here. Excuse me. Actually, as I'm doing this, I realize a better GCF would have been, in fact, 6. So I'll get -1 here, 5 here. For 14 and 21, I see it's a GCF of 7, so I get 2 here and 3 here. And I don't know if I have any more GCFs here. 5 with 2, no. 5 with 2. 5 with 1, 5 with 2, 5 with 2, no. 2 with 3, no. So I'll just multiply straight across and get -4 in the numerator and then 75 in the denominator. Okay, so I hope that this has served as a solid review. You need to be fluent in these things such as multiplying and dividing fractions. Feel free to watch a video again, practice, work hard, tell your friends, etc. But by the time you're in the Algebra 2 course, you're expected to be great at this. So if you're not, you need to go fix it. It's not that hard a skill, just take some practice. Okay, enjoy.